All right. Better if I was more adept at understanding time and how long it takes to get from point A to point B on this island. All right, so the intent for today is to do three main things, sorry. First off, we're looking at trying to, wow, you guys are spread out. No one wants to sit at the same table with anyone else. That's typical nerd behavior. Next time we'll tell them one table. So apologize first off for being late. I did not judge how long it would take me to get from the North Shore to here the way I should have, so that's my bad. We're looking at kind of shifting how PyHawaii does things. We want to try and have something for beginners at every session and something for potentially more advanced folks at every session, and then have a bit of an open session at the end where people can talk about their questions, they can look at each other's work, they can, do free play, etc. So today's kind of beginner portion is going to be on built-ins, functions that are built into the Python language that can help solve problems so you don't have to recreate the wheel. And if all goes well, we'll spend about 30 minutes or so on that. The more advanced portion is going to follow on to what we've been doing in terms of data science and data analysis. We'll keep looking at pandas, which is a data analysis library, and we will cover some means of grouping data into like categories and aggregating data in various ways, maybe looking at maximums and means and medians and other things. And then for the free play, that's basically it. We'll just kind of open the floodgates. If people have questions, or if people just want to sit quietly and work on things, or somebody wants help from a mentor or something. So with that, let's see what we can get. Start with the built-ins section. And history grep. Line 106. All right. We're going to take an overview of built-in functions. So there's a wide variety of functions that come built into the Python language, and they give you the ability to do any number of kind of common computer science types of activities. The main categories that I kind of lump these into loosely are testing things from a Boolean perspective, true and false, looking at things from a numerics perspective and how to manipulate numbers in various ways. And when I say numbers, I mean hexadecimal, binary, integers, etc. We'll look at kind of character conversion and the identification of characters and objects. We'll look at characteristics of objects. We'll look at basic manipulations and comparisons, and then some sequence manipulation. If anybody has any questions at any point, stop me. Mostly the intent here is to give you a sense that these things even exist. It's not so much we're going to dive into every nuance of each of these. It's more, oh, wow, I didn't know you could do that. And hopefully we'll point you in the right direction so that you can go and find more information about these. All right, so I'll start off. Python is often described as a language that comes with batteries included, and that kind of has two nuances. There's these built-in functions that make things very easy for specific use cases, and then they have this standard library with lots and lots of modules and packages that have very important skills built into them and tradecraft built into them so that you can solve larger problems. Today's conversation is not going to go into the standard library. That's a long sequence of talks as opposed to a short 30-minute overview. So we're going to focus on the built-in functions today. These are the ones predominantly we're going to look at. We have dir and help, which kind of give you some insight into what's available to you. We've got things like bool and hex, which handle different types of data. We have some things that do analyses, and each one of these we'll walk through. If you have questions, feel free to ask. In order to do this kind of analysis, I'm going to start off by making some data sets, essentially, or some variables. I've got emails, which is supposed to be a bunch of numbers, how many emails somebody has received or sent. I've got a string that I refer to as heroes. The string has the word Justice League in it. I've got issues, which are how many issues of a cartoon Bruce Wayne or Selena Kyle or Clark Kent have appeared in. I have the real names of particular superheroes, whether it be Selena or Barry or Bruce. And then I have some things that Python considers to be true or false. And when we talk about something being true or something being false, you might hear people say truthy. So in the Python world, the number 1 is true or equivocates to true. The number 0 equivocates to false. The keyword, capital T, R-U-E, equivocates to true. Capital F for false, equivocates to false. And then if you have a string that's got anything in it, doesn't matter, that equivocates as to true. An empty string is equal to false. And the keyword none is also false. And we'll see some of that and see all these things in use as we go along. This is just to set the stage and give us something to play with. I mentioned there's lots of built-ins. I showed you a short list that we're going to cover today, but there's far more than just that. So the first built-in is the dir built-in, and we'll use it to figure out what other built-ins there are. If you type dir parentheses underscore underscore built-ins underscore underscore close parentheses, and you run that, it'll actually give you a list of a variety of items that are built in. We're going to see some things that are written in capitals, and those will be classes. Most of those we're not going to fuss with today. We're actually going to look for functions that we can use. So I hit enter, and we see, as I predicted, there's a bunch of things that are capitals, like lookup error, name error, resource warning. We're going to skip those for now, and we're going to start looking at just the stuff that has no underlines in front of it, like the word all, any, dict, dir. There's far more here than we can go through in a single night. I leave it up as an exercise to the student to kind of poke and prod at some of these, and I'll show you how you can poke and prod at them to get more information. All right. Another thing that we can do is we can use the help function, which is built in, and we'll ask it for more information about the built-ins. I find this somewhat less useful, personally, because it fills up your screen with a whole ton of things. It tries to spell out all the details, but it's generally too much to kind of absorb. Starts going into details of all the classes and the things and the methods, especially hidden methods. I find using dir points me in the right direction for what built-ins exist, and then if I want to know about a specific one, I can ask questions about it. And we'll see how to do that in a second. So there are 2 ways that I typically ask for information about a particular function. If you're using IPython, which I highly recommend, it's as simple as typing in the name of the built-in and putting a question mark. So here I typed in bool and I had a question mark after it and I hit enter, and it spits out the help string for the Boolean built-in. And it says if you have a object and you put it in the Boolean function, it will spit out a value of true or false. If the argument x is true, you'll get a true back. All right, so we could try that. We could say bool, and we put the word true in there, and sure enough, it spits out a true. I told you that a 1 is essentially equivalent to a true, and sure enough, I put a 1 in there and I get a true back. If you're not using IPython, you can always use the help function and just put in the built-in that you're interested in. Say, tell me a little bit about bool, and it will pull back documentation for that. It expands on what you normally see from IPython, and it gives you some more details, some of which are, not necessarily what you need to look at this particular second. But the very first part that I've kind of highlighted there, it's all there. The things that we saw a few minutes ago tells you how to use it and what it's for. All right. To get out of that help screen, just press the Q for quit. We already did that. We saw that that worked out fine. All right. Now we're going to start to play with Booleans and look at some ways to test them. I'm bringing back the true values and false values that I showed you a minute ago, just to kind of refresh our memory. And I'm going to use a for loop. For every item in true values, what I want to do is I want to process each item. I'm going to process it by running it through the Boolean function, and it'll spit back something. It'll say true, false, true, false. I've created a short string here. It's got two placeholders, and those little squiggly lines are the placeholders. The backward slash and the T is a placeholder or a formatting string for a tab. So it should print out something, a tab, and something. I save that as result. When you have a result and you call the formatting string or the formatting method on any string, you can funnel results to put into the placeholders. So whatever comes out of this, if I get a true result or a false result, that'll fill in wherever this first placeholder is. And when we print out the item, whether it be the number 1 or any old string, that goes into the second placeholder. And you'll see what this looks like when we run it. And then we're going to do the exact same thing. But this time we'll walk through each of the false values, and we'll use the Boolean function to test them and tell me whether or not they really are false or not, and to print out the results. Notice here in my template string that I made, print. I didn't use a tab. I chose to put kind of a little arrow in there. Your template strings can have anything you want in them. And when you create them and you got your little placeholders, the format method can fill in all those placeholders, and it comes out pretty neat. All right. So we see the first one, there is a tab between true and 1. There's a tab between true and true. And it correctly identified each of those as being true. And we see that in the last batch, it correctly identified that all 4 of those things really were false. All right. Cases where you might use something like this, if you don't know what you've gotten from a user and you want to find out if it is true or false, you might be able to run this type of a test. All right. We'll move to a new built-in function. This one is the all function and the any function. The all function, as you might guess from the name, will look at a sequence of values, and if all of them happen to be true, it will give you back a response of true. If any of them happen to be false, it gives you back a false. Now the any function has kind of the converse use. When you hand it a sequence of values, if any one of those things is true, it gives you a true. If they're all false, it gives you a false. So when I run this, it'll test the true values to see if they're all true, and we should get the word true back. It'll test the false values to see if any of those guys are true, and since they're not, we should get a false back, and which we did. We got a true and we got a false, just like we expected. So this is one of those techniques you can use when you have a lot of details or a lot of information and you want to kind of confirm whether or not all of them turned out to be true or all of them have a positive result. You can use this. If you're looking for the reverse, you can put the word not in front of them. And you can say, not all of these are true, or not any of them are true. And it works exactly the same way. All right. Next built-in function, and again, this is kind of meant to be a high-speed overview of these things. The next built-in function is the hex function. If you give it some numerical value, it'll spit it out as a hex value. So the hex value for 15 is F. Where do we use hex values? They're often used to identify colors, for example, on web pages. A lot of colors are identified by a sequence of 6 hex values. There's a famous Twitter feed that's gone out about PETA. Someone apparently looked at the background color for the PETA website, and the hex value code for that color of blue is something along the lines of BEEEF, beef. So apparently trolling PETA. All right. Here I've got 3 different integer values. And I've got them kind of in a list, and I'm going to look at each one of them, and I'm drop each one of those into the hex function, and we'll see what hex values we get back. And this is a little bit of programmer humor here. We get things like dead beef or baseball or debatable back. All right. So hex, useful for producing hex values when you need them. The integer function will take a value. It could be a hex value. It could be some other value. And it will create an integer for you. It will create a whole number. In this case, I use the hex value dead, and we get 57,005. Python comes with a binary function. It comes with an octal function to convert things into binary, convert things into octal. I'm not going to demo those. I'll leave that up to you guys. Just know that they exist. The next function is the range function. This is really good if you want to cycle through things a certain number of times. At its very simplest, you just tell it a number. And in this case, I put the number 10 in range. A nuance that you need to understand is how it reads that number and how it understands it and what it spits back out. So when I run this snippet of code, I'm going to call the range function. I'm going to give it a number of 10, and it will store that with a variable called myRange. And then I'm going to ask it to show me what's in my range, and we'll see. And it says range starts from 0, comma 10. Right? By default, if you give it a number, it will interpret that as being the ending number. And I'm going to caveat the word ending, but it'll interpret that as the ending number in your range. It will start at 0 by default. You can tell it otherwise if you want. And when I said the ending number, with the range function, it goes up to but doesn't include the number you give it. So if I asked it to display all the content here, it would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it would stop there. I would get back 10 values, because if you start with 0 and go to 9, that's 10 values, but it won't give me a 10 back. All right, and that is on purpose. It's designed that way. If I want to see the stuff that's in it, because I mean, it just kind of spit out this thing that said range 0, comma 10. If I want to see what's in it, you can cycle through that in various ways. One of the most common ways to cycle through a range is to use a for loop. Here I'm going to say, go from 0 up to, but not including 10, and just print out each of those numbers for me one by one. And it does. You want to see how you can use range or any of the built-in functions. Again, you simply ask for help. So I'm going to type range and question mark, and you'll see it shows two ways of using it. The first one is to just give it the stop, which is what I did. I gave it a 10. It also shows that you can give it a start if you want. You don't have to use 0. It shows that you still need the stop. And notice that they've got this second bit here in brackets. A step is optional. If you want to have it increment up by some certain amount, you can give it the step to go up. So let's test that real quick. We'll say range. We'll start at 10. We'll go to 15, and we'll increment by 2. It gives me back this range object. If I want to cycle through, I can say for item in range, print the item. There we go. And it prints out a 10, a 12, and a 14. And even though we're using steps, it will not go up to the last number, right? So it doesn't go up to 15. All right. Here I'm going to start at 10, go to 100. I'm going to increment by 10s. But this built-in function, and I'm going to drop it right into another function. I'm going to drop it into the list function. Explain what a range object is before I run this. What a range object is actually a kind of construct in memory. It's called a generator. It does not produce a sequence of numbers and store them in memory for you. It produces a starting point, an ending point, and an increment if you need one, and it keeps track of where you are at any given time. So when I threw that range object into my for loop, the first time it went through the for loop, it said, give me my first object out of the range generator object, and it spit out, for example, a 10. And then it made a mark in memory to say, well, we used the first thing that he asked for. Now we're going to point at the second thing. So when he asks us for the next item, we can give him that second thing. But it doesn't clutter up memory. So if you wanted to create a range object that had, say, 500 billion things, it does not take up 500 billion spaces in memory. It takes up 3, essentially a start, stop, and a step. And it knows where you are at any given time. One of the nuances that you should be aware of is once you've gone through a range object and you've used it all up, it's gone. If you want to go through it again, you have to recreate it. It doesn't automatically reset back to 0 or to the starting point. But what if, for sake of argument, you wanted to get all those numbers out and you want them right now? You don't want to use a for loop. You want to produce them all for some reason. You can dump them into a list, and it will basically cycle through the range object. It'll grab all those things and it'll put them in the list for you quite nicely. So let's try that. And here I have a list. I've got all the items. Notice it did not go up to 100. You don't have to use a list. You can use any of the common factory functions. If I wanted a set that had the numbers 10 through 90 in them, if I wanted a tuple, if I wanted a frozen set, etc., put a range object into any one of those things, and it basically causes the generator to generate all the things and store them in your list or your tuple. So quite convenient. All right. I'm going to pull back emails. I showed it to you earlier. I'm going to print it on the screen, and then we're going to sort it using a built-in called sorted. So the original started with 99 and went up to 101. We had 87, 78 in there. And the sorted version starts at 78 and ascends all the way up to 101. For the record, to clarify a couple things that the sorted built-in does. One, it uses what's called a stable sort. Two, let me define a stable sort. So a stable sort is a sorting mechanism where if two things are already in a particular order and your sorting algorithm needs to shift them around, it will maintain their relative order if need be. So for example, say I had a tuple and it had maybe my name in it and my age. And there was someone else, for example, that had a tuple and it had their age and they had maybe a similar name. If we wanted to sort these by name or sort them by age, let's say we're going to sort by name and say the guy's got the same name as I do. But in the list, his name, for whatever reason, happened to come in front of mine. When we shift them around and we're kind of putting those two names in front of somebody else who has names further in line than mine, or putting them after somebody else whose names come alphabetically before ours, they won't accidentally swap those two around. So if mine came after his in the original order, when we shift them up and down, we'll still maintain the same original order. That's what it means to be stable. There's benefits to doing that. There's some disadvantages to doing that. It's one of those computer science things, right? I'm not going to go into much detail. Just know that when you do a sort, it will be stable. And we'll see probably an example of something like that later on. All right. Let's see. I'm going to print out a string here. It's that hero string that we had from earlier. It says Justice League, if I remember right. And we're going to play with it. We're going to sort the string. Strings are a sequence of items, and you can sort them. The sorting algorithm uses essentially ASCII-betical order. ASCII has numbers first. I think it's lowercase letters second, and then uppercase letters third. And what it'll do is it'll try and sort those things in that particular order. When you sort a string, it will actually break them up into individual characters, and it'll make a list. So you're going to see the word Justice League broken up into individual letters. Notice it identified the space that was between Justice and League. It put the capital J and the capital L. And I got it backwards. In ASCII, I guess the capital letters come before the lowercase letters. I always mix those two up. Notice that there's multiple E's in this string, and it put them all together. If we were to go and look, if there was some magic way we could identify which of those E's was first in the word justice, and which one was next in the word league, and which one was next in the word league, you would see that all three of them basically shifted and stayed in their same relative order as e's. Let's see. What if I don't want them sorted in alphabetical order? What if I want to kind of tweak that? What if I want the J to fall into place where the J's should fall into place? You can use the key, and this is found in the sorted function, and you can tell it to use a function to look at each and every one of the items that it's supposed to sort, apply that function to each item, take the result of that, and use the result to help figure out the order. So in this case, stir.lower is a built-in function that looks at any given string that you hand it and will temporarily convert that and make a copy of it to lowercase. So what'll happen is when I put heroes into sorted, it's going to take that string Justice League, it'll break it into individual characters, it'll take each character and convert each character temporarily to lower, and it will use that to help sort. We'll see how it turns out. And notice that the J and the L fall right in where you expect them to be, after the I and before the S. You can put any kind of key function you want in. You can make your own. I'll show you an example later. All it has to do is be a function that essentially takes a single argument and that returns a single result. All right. So here I'm going to bring back emails again, and I'm going to use the reversed function to reverse it. We started out with 99, 98, 87, and 101, and we get this thing back called a list reverse iterator object. This, like range, is a generator. It will actually produce the first reversed item, the second reversed item, the third reversed item upon demand. But it's an actual object in memory. And again, part of the reason for doing this is you only have to have 3 things in memory. You're not making an entire copy of your original piece of data and storing two copies. But if you need to, you can get away from that. Just right now, we're just going to use a for loop to go through that generator object. I'm going to take all my reverse emails, and I'm going to take the counts, how many emails somebody got on a given day, and we're going to go through each of them. Here's a little tweak that we're adding this time around, though. Normally, when you print, there's a new line character at the end, and it will print each item on a new line. Here, I'm going to override that default. And I'm going to say, you know what? When you print the count, put a space after it, and then wait. My for loop will go to the next item. It'll print the count and put a space after it. And it'll print all these things on the same line if everything works out right. Notice it is reversed order. It used to be 99, 98, 87. Now it's 101, 78, 87. Thing to note, this does not sort. It just straight up takes everything in reverse. In the sort function, you can tell it to sort in reverse if you needed to ever do that. But reverse just moves things in backward order. All right, next. I'm going to make 3 lists, or 3 iterables. The first one's an actual list. The second one is a tuple. We know it's a tuple because it's got these parentheses. And they're all basically the same thing. ABC, ABC, ABC in different languages. The last one, though, notice has got 4 items instead of 3. And we're going to use the zip function. I'm going to zip these guys together. And just like a zipper, when you zip things, you take an item from each of these 2 things, you put them together, take the next item and put them together, the third item and put them together. And we're going to pair these guys up. So A should theoretically be paired with alpha, B should be paired with beta, and C should be paired with gamma. But no, we get a zip object. Again, it's a generator. I can go and use a for loop. I can spit things out using list to get all of them at once, etc. So let's play with this a little bit. I'm going to use a for loop. For every pair in zip, I want to print that pair, and then I want to put some gobbledygook. Notice, instead of using a space, I'm going to actually have it print something out. There's no reason for doing this, just to demo that you can. All right. So notice it spit out an A and an alpha, and it produced a tuple. Produced a B and a beta in a tuple, and a C and gamma. Something to note, at the end of the first printing, it put this little double bracket. and at the end of the third printing, it put the double bracket. It wasn't inherently obvious that it was printing something before because I was using a space. But on the very last one, it still does put something after it. All right. One really useful way to use the zip function is to actually produce dictionaries. And dictionaries are keys and values that are paired together, just like a regular dictionary that you might be looking at, where you have a word and a definition. So if I zip L2 and L1 together, and then I dump that into a dictionary, it'll use all of my items from L2 as my keys. It will use all of my items from L1 as my values. And if I print out the dictionary, you'll see that it actually is a dictionary. There's going to be colons in there to separate each key from each value. And if I wanted to get a single value back, I say, all right, here's the key beta. Tell me what beta is associated with. I can call it up using this notation. So let's try that. All right, here's my dictionary. Beta is associated with B, alpha is associated with A, and gamma is associated with C, just like we wanted. Notice that because I used L2 first, it was selected to be the values or the keys. And lastly, when I said, hey, tell me whatever value is associated with the key of beta, it spit out a B just like we expected. You can use more than 2 items in a zip. You can zip as many things together as you want. Here I'm going to zip L1, L3, and L2 in that order. So the Hebrew words that were contained in L3, those are going to be in the center. The nuance with zip is it will keep zipping successfully until it reaches the end of the shortest item. So remember, zip 3 had 4 items in it. All the others had 3. So it will stop, and it will drop silently, daleth. And that's on purpose. Just be aware that it happens. It's not going to warn you that it dropped something. It's not going to say, hey, whoa, 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 I ran out. It's just going to do it. So we run it, and sure enough, A, aleph, and alpha, they all get paired nicely, and daleth is not there. All right, next. If you have an integer and you want to figure out how that integer is tied to a character in ASCII or Unicode, you can request that information. So I'm going to take the number 97 and say, what letter is that in ASCII? And it should spit out an A, I think. There we go. If I have Unicode and I want to know what other characters are out there, like this one, let's do this guy. Let's use the integer first. Gives me this really crazy symbol. This is apparently from the Tamil language, and it's a symbol for the number 1000. Tamil, if I remember correctly, comes from places, it's used in places like Sri Lanka and Singapore. Right? This hex version will produce the exact same thing. So you can feed integers or hex into the CHR function, the character function, and it'll spit out what character is represented there. You have a character, but you want to know what code point it is referred to, you can use the ORD function to look for that. And sure enough, A comes back as a 97. If you want to know how long something is, how many items are in my list or how many items are in my dictionary, you can use the len function. And I'm just going to use len to ask me about to interrogate 3 different things and get the results. We see that the Justice League string is 14 characters long. We see that the number of issues dictionary that I made was 5 items long. If you have something but you're not sure what it is, like, wow, is this a string? Is this a tuple? Is this a list? I'm not sure. You can use the type function to ask, what is this thing? And I'm going to caveat that. So here we see that emails was purportedly a list, heroes was purportedly a string, and issues was purportedly a dict. Type is good for rough, down, and dirty evaluations, what things are. But if you have to know for sure, if you're going to like put programming logic in based on the results of this check, there's actually a different function you want to use. Get to that in a second. If you're curious what a variable is, you can interrogate the variable directly in IPython by using the question mark. And notice when I do that for emails, it tells me, hey, this is a list. It actually shows me a string representation of that list. It tells me automatically how many items are in it, etc. Now I said that purportedly type will tell me what something is. There are cases when you get into working with classes and object-orientedness and you have inheritance of things, that stuff can get a little bit murky, especially if you have multiple inheritance from different directions. So type can sometimes mess up and provide a result that's not what you expect. If you use, wow, this is going to fail epically, so this would be cool too. If you use is instance, you can check to see is a variable an instance of a particular type, and you could say list or dictionary or string. I inadvertently put an S in here, so this is going to fail horribly. It says, all right, so there is no such thing as is instances. So let's do this the right way. And is instance, I think. I'm going to say, yeah, emails was actually an instance of a list. Let's see if it's an instance of a string. And we get back a false. You can test things. I mean, this might be important when you're not sure what you're getting, especially if you're interfacing maybe with another program and they might provide you data and you're not 100% sure what they're going to give you. Are they going to give me this or are they going to give me this? And maybe your program logic depends on what they provide you. Right? Enumerate is one of my favorite functions. I know that probably sounds a little weird to have a favorite function, but this one will actually parse through a sequence of objects and it will provide an index for you. In this case, I'm going to look at all those real names like Wanda and Selena and Bruce and Barry, and we're going to enumerate them. And we're going to get some numbers back that'll be paired up with each name. So Barry ended up getting a 0, Hal got a 1, Selena got a 2. Whatever order they were in that list. It's not necessarily inherently useful at this point, but let's play with it a little bit. I'm going to create another string, and it's going to have 2 spaceholders. I'm going to have a number assigned to my hero that I'm going to put in the first placeholder, and I'm going to have the name of my hero in the second placeholder. I'm going to do that in enumeration, and if you recall, the enumerate produced a tuple. Tuple's got 2 parts in this case. It had a number, which is the first item, and it had the name as the second. With tuples, a list, you can unpack those. You can break them apart. So rather than using the tuple as a whole, I'm actually going to break it into 2 parts. I'm going to say I want to use the index as a separate entity. I want to use the item as a separate entity. And I use the format function. And I'll take that index that I pulled out, and I'll take the item. And now we're going to print the strings. And we get that hero number 1 is Barry. Hero number 2 is Hal. So how is this different than the last one? There's something different here. Not just the formatting. The first one, Barry was first, and he was a 0. The second one, Barry's first, but he's a 1. Right? You don't have to rely on the default. If you notice up here when I put enumerate, I didn't have any numbers in it. I told it, don't use 0 as your default. Start counting from 1. If you're processing numbers in some sort of a fashion, you're like, hey, I need to start at 100. You can tell enumerate to start at 100. So that's pretty convenient. All right. If you have a sequence of numbers or a sequence of items, you need to figure out what the minimum item is or the maximum item is. They have a function to do that. So if you remember, emails was a bunch of numbers. I'm going to ask for the biggest number, the littlest number, and we get that. 78, 901. If you want to round a number, you can tell it to round. You give it the number first, and you tell it how many decimal places you want to round to. The default, I think, is to round to 0. Here I'm telling it to round to 2. And we get 13.14 or 3.14. If you got a bunch of numbers and you want to add them up, we have the sum, and we're getting really close to the end of this. If you want to ask your user for data and you're on the command line, you can say, hey, here's a question for you. And when you run this script, it'll print out who's your favorite Justice League hero, and then it'll sit and it'll wait patiently until you type something. All right? So it says, who is your favorite Justice League hero? And we'll say Selena Kyle, right? And then once it gets that input, in this case, I'm assigning the results of the function to a label called best hero, and I'm just going to have it print best hero immediately after I hit enter. And there you go. So you can get input from your users. Right. If you want to read a file, the open command is useful for that. I'm going to show you 2 different ways to use it. This is fast and dirty, and I'll show you essentially the right way to do it. But in this case, I use open. I tell it what script to open, and I'm actually going to open the script we're using right now. I'm going to open it for reading, and I'm going to give it a file handle name. I'm going to call it fin. And this one screwed up too. It's going to fail. All right. Let's see, fin.readlines. And you see it read in all of the lines. We're getting close to the end here, and we just kind of looked at these lines right here. All right. And so we'll look at the last one. This is quote unquote the more proper way to do this. It uses the with term. With is a context manager. I'm not going to go into all the details, but you tell it with the open function, taking the results of that and using them as fin, do something. And within this context manager, I indent all of the stuff that I want to happen within the context manager, and it'll process them. Some of the magic that happens behind the scenes with a context manager are things like it handles kind of error conditions a little more gracefully. When I get done with this particular file and I step out of the with context manager, it will close it for me automatically. I don't have to do that, etc. So it kind of cleans up your mess as you go, those types of things. It doesn't have to be with just opening files. It can be with opening connections to databases, etc. There's a lot of different cases where a context manager is useful. So in this case, with open, we're going to open the same file. I'm going to give it a file name as fin. And instead of using read lines, I'm just going to say for every line in that file, I want you to print odd characters of that line. And there we go. And it printed all of them and just gave us the first 20 seconds. All right. So Whirlwind Tour, that's built-in functions. Before I get into kind of the advanced conversation, any questions on any of that? No. All right. Sweet. Wouldn't hurt my feelings if people asked questions. That's okay. Let's see. 182. All right. So this one deals with pandas. For those who haven't been here before, for about the past 7 weeks, we've been going through a library called pandas. It's used for data analysis. The stuff we're going to cover here is not necessarily tremendously complicated. It's more of also kind of a high-level view of what you can do with pandas and why it might be useful and help you out. Tonight, we're going to look at if I have data, how do I group it? And how do I use those groups once I've made them? And if I have data, how do I aggregate it? How do I use that aggregated data? I'm going to start off and I'm going to read in some modules and functions from various libraries. From the pandas library, I'm going to import pandas, but I'm going to give an alias of PD. From pandas, I'm going to import data frame, which is kind of like a dictionary, but on uber steroids. It basically creates a spreadsheet style of data type. A lot of times you'll see that people would just import series as well, but in this script we don't need it, we don't use it. And later on we're going to use numpy, and I give it an alias of np so it's easier to type. For those who haven't sat through the past couple of weeks, I'm going to gloss over a lot of the magic of why I'm doing certain things because we've covered some of those. If you're really interested, hit me up after the conversation. I want this to kind of go fairly quickly. So I'm going to make a data frame. I use a dictionary to do it. Each of the keys is a column header. Each of the values is the data to go into each of the rows. So I'm going to have a column called name, and it's going to be filled with things like Diana, Diana, Clark, Clark, and Diana. On day one, I'm going to have some values like 10, 11, 23, 23, and 15. And I'm going to have these messages that will say, well, there was 10 emails or 11 tweets, 23 emails, 23 tweets, that type of thing. And sure enough, that's what we get. What I'm going to do is I'm going to take the day column and I'm going to group by the names that were in the name column. And we had Diana and that other guy. Let's go look at this. And we get back this horrible thing, right? Again, it's an object. A group by object is actually a reference, or it's kind of a pointer system. It is not actually a data set per se. What a group by object does is it says, you know what, you had this spreadsheet style thing, and you had a row that had some guy's name in it. You had another row with the same name and another row with the same name. And those were rows 2 and 4 and 5. If you ever wanted to do something with this group by object, you should use 2, 4, and 5 to be your first group. And you should use rows 1 and 3 or whatever to be your second group. So it's basically a series of pointers. But you can use those pointers to get to the actual data, which we'll do here in a moment. All right. All right. Group by object, because it's pointing at things, you can say, go through each of those pointers and get me those details back. So I'm going to say for every item that's been grouped or identified, take each of those blocks and then start printing out the individual components. And we'll see how this plays out. We start off with Clark, and underneath Clark, we have a row that has the number 23 in it and another 23. We see that it came from a day column called day 1. So on day 1, Clark had 23 items happen, and he had another 23 items happen. We lost a little context because I didn't actually ask for the messages column, but we'll see how we can get some of those things later. A couple things to note. On the left-hand side, Clark has a number 2 and a number 3. That's row 2 from the original data set, row 3 from the original data set. Diana had rows 1, 0, and 4 from the original data set. So you actually have a way to kind of trace back to where you started from if you needed to do that. When you have a grouped by object, there's a lot of functions that are associated with those that are built into group by objects. You can say, give me all of the average values associated with each of those groups. And it says for the Clark group, the average value that associated with Clark group was 23, and the average value for Diana was 12. So it's very convenient for taking groups of stuff and starting to manipulate your numbers. All right. If, for example, you want to do a hierarchical grouping, you say, all right, I want to group this by name, but I also want to group by the type of messages. I'm going to say, give me back just the day 1 column, and I want to group by the name, and then secondarily, I want to group by the message type. And you can immediately, if you'd like, apply a function that's associated with a group by object, like mean, and just get back the mean values. So you don't even have to stop at that intermediate step. You can just jump right to the data you really want. So in this case, Clark had 2 sets of values. He had a 23 and a 23. We couldn't see it before, but one of those 23s was how many emails he got. One of the 23s was how many tweets. And we see that in this case, because he only had 1 value for each, the average is, of course, 23. But Diana had 2 rows that were associated with emails, and she had only a single row that was associated with tweets. So it took the average of her emails and gave us this 12.5 back. And it took the value that was associated with tweets and gave us that back. We see that it's got this hierarchical structure that we asked for. We asked for to break it down by name and then by message type. So that all worked the way we want. And again, if you're picturing a data frame as kind of like a spreadsheet, this is a very convenient way to really run through large sets of numbers, etc. Now, I asked for it to show us the means a second ago, and it gave us kind of this format. Clark had some email, he had some tweets, and that works. But if you want to unstack those, so maybe see the emails and tweets side by side instead of one on top of the other, unstack function to do that. And here we show, here's the name of the person, and then we show the messages. And now it's a little bit more of a tabular format, makes it a little easier to read. All right. I'm going to use the NumPy module, and they have a method for making arrays. In this case, I've got 5 items in my first array: New York, Baltimore, Baltimore, New York, New York. And then I've got another array that's got Monday, Monday, Tuesday, Monday, Tuesday. And I'm going to use those as keys to kind of sort the data. I'm not limited just what's in my spreadsheet. If I want to have a key to help me do some sort of manipulation of that spreadsheet, I can create them on the fly. So in this case, I'm going to create an array that has these city names, and I'm going to have an array that has days, and I'm going to ask it to sort those tweets and all those other things as though these 2 items were columns in my spreadsheet. So it will look in here and it will find everything associated with New York, and it will then look and see, this first New York item, the first row in the spreadsheet is supposed to be New Yorkish, and it is supposed to be a Monday. The second row should be Baltimore, and it should be a Monday. The third row will be Baltimore and Tuesday. And it will essentially, on the fly, assign these keys to each row, and it will allow me to group them. And I'm going to go back and I'm going to say, give me the means for these, and it'll look in the day column, and it'll figure out how many messages were sent, and it'll give me the average. So here we see that in terms of Baltimore, Baltimore was associated with Monday and Tuesday, and it gives me the average number of messages that were sent on Monday and the average sent on Tuesday. Notice that New York, the average sent on Monday was 2 values, and it turned out to be 16 and a half. You've got a spreadsheet, a data frame, and you want to group by just a single element, and you want to get the entire spreadsheet back, the entire data frame back. I'm going to say group by just the name column, and it'll give me everything back. So it grouped by Clark and Diana, and I see all the data for day 1, all the data for day 2. But I went ahead and asked, and I said, you know what? Instead of giving me each in a row, I want you to go ahead and calculate the means for me. So we see the means for Clark on each of those 2 days, and the means for Diana. Right? If I want to group by more than 1 column, but still get the entire spreadsheet back, or the entire data frame back, you can do that. And here, we've got this hierarchy breakdown again. All right. Now, if you want to know how many items are in a particular group, you can ask it that question. You say, tell me the size of each group. So we see the Clark group had 2 items in it, and the Diana group had 3. Works. This may fail epically. This is what you get when you get live demos. Yeah, epic fail. If I want to do this with 2 columns, you can do the same thing. Here we've grouped by Clark and Diana as well as the messages, and we see how many of each of those things show up. All right. Now say you want to get into the different parts and pieces of this group by object, and you want to play with it. You're going to do some manipulation on that data. I mean, it's one thing to see it, but here you want to work with it. Every group by object is iterable. It means you can dump it right into a for loop, and you can start to play with it. And you say, all right, take the first group out of my group by object, which is probably Clark's, and take the name of that, in which in this case it should be Clark, and then take the actual group, the actual content, and we're going to display those separately now. Because group by objects behind the scenes are tuples, you can unpack them. So I'm going to unpack the first part of the tuple into name and the second part into group, and we'll print each of those. All right. Sorry, it wasn't Clark and Diana. I was grouping by the messages. I apologize. Should have read my own code better, right? So the types of messages that we had were emails and tweets. And it says, okay, so I'm going to take the first group, which is the emails, and we see that some emails were sent on day 1 and day 2, and we see who sent them. And notice this first group is composed of absolutely nothing but emails. The second group in my messages grouping was tweets, and we see that Diana and Clark both show up with those. So you can actually break this down into parts and see each one of them and manipulate them one by one if you needed to. My last group that I played with there was, the tweets group. And now that I have it, I can manipulate it in various ways. If you have a hierarchical index, the last one we looked at was just indexed by messages. But if I want to index by name and messages, I can break each of those guys out independently. The first part of the group by is going to be both of those keys, and it'll be the group. So I'm going to print the two keys on a separate line. I'm going to print the group on a separate line. And we see that the first group that we had was Clark with his email. The second was Clark with his tweets. And the third one was Diane. And again, if I just want to look at that last group that we played with, it really is just Diane's tweets, and we see that they only have a single row. All right. Here I'm just printing them, right? But you can do manipulations on them if you choose to. You say, what kind of manipulations can you do? You can apply functions to them. You can round them. You can ask for the means. You can get just the values to spit out. If you find that there are blanks or spaces in them, you can do forward filling or backward filling to kind of fill in blanks or gaps. If you want to iterate over them in some way, you can do that. If you want to change the shape of them, maybe it's in a table and you'd like to have it in a row to flatten it out. All of these things are available to you to work on any one of those groups. And as we go through this conversation, keep this in mind. Anytime you have a group, if you look at a given group, you can do any one of these things to any group. You can write it out into a new data format. If you wanted to have your group written out to HTML, for example, because you're going to put it on a web page, you can do that. If you want to write it to an Excel spreadsheet, for instance. If you need to put it into JSON to get it into another data set. If you want to drop certain values, because those aren't really pertinent to our data because there's some confounding value or something. If you're into data science and you want to find the variance of it, we have built-in calculations to do the variance or the standard deviation, etc. So there's a lot of playing that you can do. This conversation is more about how do I get it into a group, less about what can you do with it once it is a group. We've already looked at a bunch of these things in some of the previous pandas conversations, so I don't want to spend time on what you can do with a group. We're looking at how you get groups. All right. So in this case, say you've got a huge data set. There's maybe hundreds of columns. And you want to group by just the names and the messages, for example, and you only want to see the days. You can segregate off which columns you're interested in. And notice down here, I can index to say, show me day 1 and day 2. What if I had columns for all the days in a month, days 1 through 31? And in this case, I'm just going to ask for the means again. Keep it simple. Okay. So next, I'm going to make a brand new data frame. This one is got 5 columns. They're represented by years 2012 to 2016. So again, anytime you make a data frame, you can tell it the names of each column as you go. I have 5 rows in my data frame. Each row has got its own individual set of numbers. In this case, the 512 will be in column 1, the 413 will be in column 1, 501, etc. And my index, instead of using, we saw earlier that we had an index of 0, 1, 2, 3, 4. In this case, I want each row to be identified by a person's name instead of a number. So row 1 will be, or the first row will be Clark's interactions. The next row will be Bruce's, and then Diana's, Kara's, and Selena's. The mapping that I've got here, it's just a dictionary, and it says the year 212 should be associated with a thing that I'm calling pre. The year 213 should be with pre, and the year 214, 15, and 16 should be post, and the year 2017 should be the future. So let's just pretend that in the superhero universe there was some sort of apocalyptic event that happened somewhere around 2013, 2014, and we wanted to learn about activity that the superheroes had engaged in pre-apocalypse and post-apocalypse, and maybe we want to sort out potentially things that might happen in the future. So I'm creating a labeling mechanism that we're going to use in a couple minutes. All right. So I called my labeling dictionary mapping. And I can go in and I can say, all right, I made this heroes data frame. I want to group by, use my map to group things together. So the column 2012 and the column 2013 will be grouped together in a group associated with the label pre. 14, 15, and 16 will be associated with a group called post. And if I had a column 2017, that would be associated with a group called future. In this case, I'm going to tell the group by object to use the axis 1. And axis 1 is shortcut for saying use your columns. The default is to use axis 0. You don't have to tell it that. It automatically does it, and it starts to group by rows. But I want my data grouped by columns, so I use axis 1. Once it does this grouping, it's going to store it in this thing, and I'm going to give it a label of by column. And I'm going to say, you know what, take this by column grouping and show me all the sums. So show me all the sums that are associated with everything that happened pre-apocalypse. Show me all the sums that happened post-apocalypse. And there you go. It breaks it up nicely. Pre-apocalypse for Clark was 512 plus 613. That is, somebody do the math for me. If you add those two together, 512 and 615. 512 and 613. Yep, and that's what we get. Bruce would be 413 and 412, so that'd be what, 825, and sure enough, that's what we get. So here's the thing, though. In my data set, the year 2012, 13, those were kind of first in the spreadsheet. 14, 15, 16, they were second in the spreadsheet. But oh, woe is me, my table is kind of wonky. Post showed up in front of the word pre. And that doesn't really kind of jive with how we picture chronology, right? Anything that happened pre-apocalypse, we might picture as being to the left of the event. Anything post-apocalypse would be to the right of the event. The reason it did this kind of swap is because by default, it orders these things in lexicographical order. It orders them by alphabetical order, basically, or numerical order. So if you don't like that, you can fix it. And I'm going to tell it, you know what, dude, do not sort. Just lay them out kind of in the order that you find them. So I set sort equal to false. We do the exact same thing. And we see that the values are now kind of more the way we might want to picture them. In this case, I chose to do summing. Again, it's a group by object, so there's a whole slew of types of aggregations that we can do. We can do a cumulative count. We can do a maximum. We can do a median or a mean evaluation. We can do minimums, etc. So lots of options available to you. All right. So now I'm going to do something different. I'm going to group by how many vowels are in the names of the superheroes. So I've got these superheroes, and they have names like Kara and Bruce and Clark and Selena. So they have various numbers of vowels. This is kind of a made-up example, kind of dumb, but I want to show you that you can make your own functions to do any sort of kind of aggregation that you'd like. Each of the superheroes has 1, 2, or 3 vowels in their name. Once I've done the grouping of all of this data, I want to take the mean or take the average of how many things occurred for Clark or Bruce or Diana based on how many vowels they have in their name. So we see if a superhero had 1 vowel in their name, they had an average of 512 activities occur in the year 2012. If they had 3 vowels in their name, like Selena, they had an average of 457. I'm not going to go through the nuances of the function. I'll leave that as an exercise for you guys. I mentioned there's lots of things you can do. You can do means and sums. I'm not going to demo those. But the describe function I did want to show off. The describe function gives you a bunch of statistical evaluations all in one shot. So here we had done that mapping to say pre and post, and you notice that it very nicely outlines which years were in the pre categories and which ones were in the post. And then it did this numerical assessment. It says how many items were in the pre column, how many for 2012, what was the mean of all those values, what's the standard deviation, percentile, fallout at? What's the 75th percentile fallout? Again, the types of things that for a quick statistical look at your data you might want to know. So describe is very useful for getting all these things in one shot. All right. So what if you want to aggregate using other means? You can create your own functions to aggregate data. I'm going to do an evaluation, say, look at an array of numbers and find the maximum value. Look at that same array, take the mean value, and I would subtract the mean from the maximum. Get this difference between the average and the maximum. And I want you to group by that difference. And here we pull out the names of the superheroes that we looked at earlier on in the day. And we see that Clark, because he only had 23 messages and 23 messages, his maximum and his mean are exactly the same. So the difference between his max and his mean was 0. But Diana had, I think, like a mean of 12 and a maximum of 15. So her difference is 3. You can put any kind of function together that you want. And you can use this aggregate item on a grouped by object to aggregate your data into chunks and groups. For the next couple of examples, I've got a data set. It's a bunch of GPAs that I made up. It's like 10 lines long. It shows a GPA, the percent change in the person's GPA since the last quarter. It shows whether they are an athlete, shows their gender. It shows whether they prefer to exercise on a particular day, and whether they exercise in the morning or the evening or the afternoon, and how many hours they tend to exercise. So we're going to read that in using Pandas read CSV module, and we're going to store that spreadsheet as GPAs. So I've got a column called the GPA change, how much it's changed since the last quarter, and I've got the guy's GPA. I'm going to divide those two to get this percentage change. How much of a jump has the person seen in their GPA, or how much of a loss? And then I want to group by their gender and whether they're an athlete, yes or no. And once I've grouped it, I want to say, all right, show me, based on that grouping, the column GPA percentage, and store that away for us. All right. And once we got it stored away, we can play with it. I want to do an aggregation on that data that we've stored away. I want to aggregate all that data by the maximum value of their percentage change and the mean. And remember, I made that funky function that takes maximum and subtracts the mean from it and calculates the difference. I want to look at that as well. Something to note, though, the max function is surrounded by quotes, and the one that I made is not. That is on purpose. If you use a built-in function, you have to have the quotes. If you use a function that you have defined, you can get away with just calling it by its name. I don't know the rationale behind that. That's just the way it worked out. So let's see what we get. So we broke it up originally by the gender and whether they're an athlete, yes or no, and the maximum percent change in their GPA for the female, non-athletes, etc. We can see the mean change and the maximum and difference. So when you aggregate things, there's lots of ways to kind of do summations and stuff. And you're not limited to doing a single summation at a time. Here I have looked at 3 different ways of evaluating the data, and I've grouped it in multiple ways. And again, I'm not expecting folks to walk out of this conversation with, you remember all of these things. This is more of a, wow, you can do that with pandas? That would help me manage my data in so many cool ways. And, you know, kind of set the stage for you to go back and look at pandas and research some of these things. And I will make this code freely available to folks so that you can look at it and play with it. If you have a collection of functions that you want to run, you can put them together, for example, in a list. And you can drop that whole list into the aggregate function and say, aggregate by all of those techniques, counting and minimizing and maximizing and medians. In this case, I'm going to look in my grouped by object, and I'm going to say, I really want to group by the percentage change and the original GPA. And we can look at the result that we got. And see, we've added the count to the end, and we're looking at the percentage change based on, and then we see it in terms of the median and the max. All right. What if you want to run a particular aggregation on one column, but you want to run a completely different aggregation on a different column? I can say, look at my GPA change column and run the minimum. Look at my duration column and calculate the mean for that column. And I'm going to take this mapping and I'm going to drop it into aggregate. And awesome. So I was playing with this script earlier today, and I made a number of changes to it. And I apparently didn't save. So let me go by and do that. Doop. All right. And here we've taken the mean for all the durations, and we've found the minimum GPA change, depending on whether you're a female athlete or not female athlete, etc. All right. I will tell you right off the bat that for the rest of these things, a number of these items got changed, so they're all going to fail miserably. So we'll stop there. Any questions? Whirlwind tour. Okay. All right. Because we started late and because both of these things were a little longer than I expected, don't have a whole lot of time for free play, but we'll make the best of it. So if you guys have questions about anything Python related, there's a number of folks in the room who are happy to answer those questions or try to answer them. If you just want to poke around at something and say, hey, can you come look at my project? We're here to help in those ways too. So with that, I'm going to call it quits. I'm going to kill the microphone for the poor guys out there in the real world, and we'll end the broadcast with that. And we are here at your disposal to beat and abuse.